Section 6.4, the central limit theory. Central limit theory is using the same formula that we had in section 6.3. The only difference here is there are two requirements, and also the standard deviation has to be divided by radical n. Where do we use it? This is a good example because it's mentioned here that we are taking one sample of 1392 earthquake, and when you do that, the graph is not a normal distribution. But when we take 50 samples and we graph the histogram, then you see a normal distribution. So when you take more samples, you get a better graph and also better normal distribution histogram. So the requirement is for us to use a central limit theory is either the value of n, when you take a sample has to be greater than 30, or if we state in the problem that is distribution is normal, is a normal distribution, then n doesn't have to be greater than 30. It could be even less than that. Now here on this example, in this exercise 5, assume that female have pulse rate that are normally distributed. So they're indicating that population is normally distributed. Mean is given, mean of population is 74 and the standard deviation is 12.5. Now, if one adult is randomly selected, when one adult is randomly selected, then we could use the normal formula. But if the adult, the number of samples is more than one, like in the case B, then we are using central limit theory. He said if 16 adults are randomly selected, find the probability they have a pulse rate with mean less than 80. So the first part of the problem is dealing with the previous sections. What's the probability of X is less than 80? The mean and the standard deviations are given. So X less than 80 means we need to find this area. This area is probability of X less than 80, which again is very simple to use the calculator. Calculator need both ends, X1 and X2. X1, when you're dealing with the X, always start from 0 somewhere. So when you're dealing with X, the left is always 0. 0 and one end is 0, the other end is 80. And then mean and standard population are given. So that gives you the probability when you randomly select one. Now, on the part B, we are taking 16 samples. So in that case, you're using the same formula. Again, the only difference is the standard deviation must be divided by radical n. So you come up with the different numbers. So when you are using the formula, then the probability increase to 0.97. So you see the difference of taking one sample, which gives you almost 68% probability, till you take 16 samples. So the probability increase is 97%. Because the original population has a normal distribution, distribution of the sample mean is the normal distribution for any sample size. So when we indicate in the problem that distribution is normal, then the value of n doesn't have to be greater than 30. Other than that, the requirement is either normally distributed or greater than 30 or both. This problem is very similar to that. So on this one, again, the mean is given, the standard deviation is also given, and that's they show you how to do the calculation for that. If one candy is selected, find the probability the weight is more than 0.8541, which they calculated here for you. And the second part is when 464 candies, see the value of n is greater than 30. And in addition to that, its function is also normally distributed. So the requirement is double. So again, it's very similar to the previous problems. We want to know the probability greater than 0.8, means this area. When we ask for this area, both end. One end is given in the problems is 0.8541. The other one, just to lose a large number, 100, 1,000, what is. So this number is arbitrary numbers. So that cover both end of this area that we're looking for. And then mean and standard deviation are given. The second part, since the value of n is greater than 30, is not 1 anymore, then all I need to do is to find the standard deviation. I need to divide it by radical n, and you put that in the formula, so probability is 0.58. So we go from 50 to 58 increase. So on these sections, the only difference is right here. When the number of sample is more than 1, or in case more than 30, then we are using this formula. These problems are all very similar. Again, the same thing. Here they're asking probability of x less than 78. Again, one end is 78, the other end is 74. See here, if one adult is randomly selected, find the probability parse rate is less than 78. So less than 78 would be all number here. So that should be 0. Again, here would be 0. 0 to 78. 0 to 78, and mean and standard deviation, mean is 74 and the standard deviation is. Now, when the selection is more than one sample, when it's 4, we understand that it's less than 30, but again, they indicate in the problem that distribution is normally distributed. So in that case, when the number of samples increase, then you take the standard deviation and divide by radical n. So you understand that probability increased from 62.5% to 73.8, almost 74%. The first two are multiple choice questions. Number 3 and number 4. Again, if one adult and 4 adult. Again, part B is when n is 4, is greater than 1. So these problems are very similar as far as the calculations. Again, the mean and the standard deviations are given. N is 461. On your calculator, you put the upper level, lower level, and so on. See again in this one, airline 150 passenger, door with a height of 74 inch. Height of men are normally distributed with 69, so is normally distributed. Mean of population is 69 and standard deviation is 2.8. If the male passenger randomly selected, find the probability that he can fit through the doorway without handing. Okay, so that means if he wants to enter, it has to be less than the height of the door, which is 74. So what's the probability of people who enter the plane have height less than 74? That should be vice versa, so it should be 74 and 0. And the other one is just a multiple choice. So this section is only based on change in standard deviations.